Yesterday, to achieve this path selection, we used R4. Today, I'll remove from R4 and I'll do it on R5 and show you how to do this path selection. R4, to remove it first. Do show RAN section router BGP 45. No. Done. Clear IPBGP star soft. Show IPBGP. Gone. Okay, so it's now the normal on router 5. I need to write those access lists, so instead of writing, I'm going to copy down from there. Show run section access list. These are the 3 access lists. And now I need to use a route map. Route map. Policy 1. Sequence number. If I don't mention, it will start from 10. Let me say 1. Policy 1, sequence 1. Match IP address 1. If that match happens, it should go via router 2. So I need to say set local preference lower. Set local preference, or better you do one thing. We'll create 2 route maps. So this I'm preferring to go via router 2. I can decrement here. I can say 50 here so that it won't go to router 3. But what if it goes via router 1? So better, we'll create 2 local preference. I'll say 200 and I'll attach this policy 1 to router 2 neighbor. Next is route map. Policy 2, sequence 1. Here I'm going to focus on this one. This should go via router 1. This should go via router 1. Which means I need to give less local preference on both policy 1 and policy 2 so that it will not go to router 2 or 3. So match IP address 2. If that matches, set local preference 50. And then sequence number. Okay, let me go back to policy 1 and say the same access list if that matches. Set local preference 50 so that it won't be preferred via 2 and 3. Next is 3 should go via router 3, for which I need to have another policy. When same policy, route map 2. This is what I'm going to bind it to router 3. I made a mistake. Policy 1 in route map match to, that is 50. That's correct. Next is same policy 2, sequence number 2, match IP address 3, set local preference 200. That's all. Now I need to simply create another one for both the policies so that it will be default. Show route map. Policy 2, access list 2, if it matches 50, which means if I bind this to router 3, it will not go via router 3, absolutely. Correct. Next is access list 3 200, which means it will be going via router 3. Yes, 3 should go via 3. And then policy 2 for rest of the traffic, policy 1. Here is the mistake done. Policy 1, if 1 matches, we prefer to go via 2. This I need to change. Policy 1, fully wrong. I'll remove this policy 1. No route map. Policy 1. Policy 1 I'm writing for router 2. So route map, policy 1, match, come on, this is funny. Router 1 is preferred. Sorry, router 2 is preferred for this 1.1. So match IP address 1, set local preference 200, route map policy 2, match IP address 2 is 2 preferred over, no, not preferred. So I need to set 50 for that. And then policy 3 simply I need to create. Show route map. Policy 1 route map. If access list 1 matches, go via router 2. There is this. Okay. Now bind it to the neighbor. Router BGP 45. Do show run section router BGP. I need to bind policy 2 to, sorry, policy 1 to this neighbor. Route map policy 1 in. As the update comes in, I want to add those local preference. Next is neighbor.
Put the neighbor commands back in R9. You removed the neighborship, right?
I did.
Okay.
So neighbor router 3, route map policy to in. Now let's see clear IPBGP star soft. Show IPBGP. According to our expectation, to reach 2 network, it should go via 1. To reach 2 network, yes, it is going via 1. Router 4 is an IBGP. If it goes to 4, it will go via 1. And to reach 3 network, it is going via 3. To reach 3, it's going via 3, correct. To reach 4, it should go via anything. To reach 1, it should go via 2. 1, yes, it is going via 2. That's right. So let us trace route and verify this. I should trace route from 7 to have a better verification. When I trace route from here, trace 999911 source loopback 0. So this is going via 2. 1 should go via 2, that is right. Router 7 takes this route. Next. Two 1, it's going via router 1. 2 1 goes via, that is right. And 3 1, it goes via 3. 3 should go via 3, that's right. 4 can take any path. It will go via 1 if you are tracing from router 7. If you are tracing from router 8, it should go via either 2 or 3. According to me, it will go via 2. Trace route 9.9.4.1 with the source loopback 1. It goes via 3, it's okay. Now 3 should go via 3 only. That's right. And 2 should go via 1. It is going. And then 1 should go via 2. Yes. Alright, so problem solved, achieved. We tuned with local preference. We have tuned with weight earlier. You know about attribute 3. It is local, advertised. And only when there is tie in all these 3, it will compare the AS path. So in case if AS path is same, like our scenario, it will compare the origin code. In our case, origin code is same, all are I. But earlier in the beginning, when we started BGP path attribute lab, I was tuning even the origin code. Originally it was I, but I made it as incomplete by using route map. So you can tune the path using origin code also. So the command is available in the route map. Let me show you that once again. We did a lab on this, but still now to remind you, I'm doing this. For example, here if you see set origin, you see I or question mark, incomplete or question mark. Now likewise you can also set metric. You can set metric, lower is preferred. Here metric here means MED, multi-exit discriminator. The default is 0, lower is preferred. So these are the things that are configurable. All the other things are automatic. eBGP path over IBGP, prefers the closest IGP neighbor, oldest route, lowest neighbor, router ID, lowest neighbor IP. These are all automatic. Yeah, not configurable. Right. So we'll do MED lab